I think the pixel map fits very nicely into what Gibson calls the retinal theory of perception, which is sort of antithetical to his view. The eye is a camera, for instance. He rejects that notion. The retinal theory, as he describes it, and I think it's pretty accurate of what the mainstream view is that the eye is a camera that encodes some image and then transmits it to the brain, which receives that image and then does computations on it. And so he emphasizes that vision is not just an eye connected to a brain, but it's an eye connected to a brain, both of which are in a head, on a body, in an environment, and that entire system is necessary for understanding vision in the context of a particular organism. And the retinal theory removes a lot of that. That's very important. He has a book from 1966, since it's considered as perceptual systems, and in it he describes all of the senses, and I imagine his last book would have he would have gone further and revisited some of the other senses had he lived long enough. But he believes, and I believe as well, that if you want a complete model of vision, then the information processing model is not going to be adequate. That's my belief.
He says the brain does not receive an image transmitted from the retina.
Correct. That is.
You can very well look. I mean, it seems to me that that's one perfectly valid way of looking at what's going on in the perceptual system.
It's the information processing model,
yeah.
And it's not a complete model.
Okay.
Not only
in
that,
Gibson's view and in my view.
Not complete. And it's not meant to be. That's not a complete model. That's just one statement.
It has plenty of uses. It has plenty of practical uses.
Okay.
And clearly, the applications like facial recognition software, for instance, a lot of connectionist architectures, HMAX and derivatives are modeled after it. What's it? Oldenhauer? Oh, I can't remember that. Oldenhausen? Yeah. And Poggio? Yeah, those guys. They've done some work which has been very useful, and it shows that this is a valid way for
Which is a valid way?
HMAX is a valid way for the connectionist architectures that have spun off of that are very useful. I mean, their technology proves that they are effective for training visual recognition software. Now, this is based on models of vision that are related to the feature detection hypothesis, and this hypothesis is not proven by the fact that these models are effective. And
so what is the feature detection hypothesis?
I've got a slide on that later on.
Okay, I'll wait.
Okay, when we talk about Freeman's work.
Well, before you, what I don't understand at this point is it says that the brain does not receive an image transmitted from the retina.
Correct.
It seems to me the statement is simply not correct. It does.
No, it doesn't.
That's what I don't understand.
What in addition to an image?
How doesn't it receive that?
There is an image that's formed on the retina.
Yeah.
The retinal cells do not create a snapshot that is shipped, to a,
I'm understanding what he's saying. That what goes in through the optic nerve is not an image. It's a lot of information, but it's not an image.
That's right.
correct.
I'm happy with that.
Okay, yeah. Well, he finds the distinction.
Now I understand what's being said.
He finds
so
the distinction quite important, and
Yeah,
I do
well,
too. I do too.
That may be.
It's easy to overlook, and I think it's kind of it was an aha for me to.
What about the rest of that slide?
I thought I did it already.
No, if
Yes,
you
I did.
I missed it.
Okay, no.
I only got
Bob has a comment. Yeah, go ahead, Bob.
One of my favorite researchers at Stanford is E.J. Chichelniski. I won't try and spell it. Chichelniski. He takes monkeys, rhesus macaques that have been used in other labs and that are preparing to be sacrificed, and he'll take out their retinas and then use microelectrodes to determine what is actually coming into the optic nerve from the retinal ganglion cells. And it's revolutionized my way of thinking about what the retina does, and it hasn't permeated to the textbooks yet. But basically he and a few other pioneers say that there are 20 plus separate parallel channels that are coming off of each retina that are transmitting different kinds of information. So for example, there are direction selective cells, there are sort of classic Hubel and Weasel contrast cells, a whole variety of different cells that are transmitting information. I mean, and this is, I think, confirming or adding evidence to Gibson's 1966 intuition that what the retina is transmitting is not a camera image, but a whole collection of different channels of information. Yeah. So that's my point number one. And while I've got the floor here, let me make a second point, which is a point that Bruno Olshausen regularly makes, and others, Tommy Poggio and others, makes, is that when you look at the input layer, layer 4 in V1, most of the neurons that are, most of the synapses that are coming into the input of V1 are actually from above. Yep. They're from the brain rather than the retina. So that further reinforces the fact that the visual world is being constructed by what we know rather than light that's hitting the retina.
Yes.
Well, that is your latter point is anti-Gibsonian. I'm not going to argue with it. I think Gibson would, or the inference that you're making from that. But I definitely think that it's highly significant the reentrancy of the cortex, even the quote-unquote primary visual cortex. A figure I read, I can't remember if it's from Edelman or from Freeman. It was 90% of the input to V1 is from the cortex itself. So
exactly.
But thank you for those points, and please interject again if you have further comments or questions. Anything else you want to say on that?
No, Steve, I don't want to interrupt your talk, although I am waiting to get to the affordance piece. I was nicely primed by Sean's talk about a year ago that's on YouTube.
Wow.
Yes, yes. Well, we also, go ahead, Sid.
No, go ahead.
We also are glad for the opportunity to get to know you, so I appreciate your consideration about the talk, and I will try to get to the affordances. We may end up going till about 5:30, but we also want to get to know you, so let's try to balance those two objectives, and please do feel free to interject again. Thank you. Okay, so,
Still haven't gotten that slide.
which part of the slide do you not,
I don't know, I
Wanna-
haven't had a chance to look at it.
okay,
I got distracted by that.
okay. All right, so the third point was the one about
Third is-
the image.
Third is clear, the fourth bullet is clear to me now.
Okay. And then the fifth bullet, I think we've talked about numerous times, that information processing model is not deemed complete by Gibson.
Okay, and the last,
That's the last one.
go ahead.
Okay. If there's an issue, okay. All right, and so we talked about some invariants in the past. There's perspective transformation is an important example, and optic flow. There's going to be some slides of these in a moment. But in general, an invariant is what Gibson describes as specification via lawful correlation. We'll unpack that as we look at the examples. And this was a point which was made in a previous talk, and when I made it, Stan, you asked me to repeat it, and so I took it as significant. But disruption of an invariant will weaken, distort, or destroy a perception. And I think some of the examples that I show will be able to make that evident, what we mean by that. So, okay, let me...
Can we come back to this slide after we see the examples?
We can.
That'll be useful.
Okay. Actually, I'm going to go to the perspective transformation slide first. And this is just a series of shapes that I prepared that create the perception of a rotating rectangle. Now this is what Gibson describes as a perspective transformation. There's a varying shape at each point, but we don't perceive different objects. We don't perceive 4 different objects, and there's a number of reasons. One is the fact that, you know, there are 4 sides that stay connected to each other. While the lengths and the angles change, they do so in a lawful way. And Gibson, and this is a simple rotation. There are also perspective transformations that accompany movement through the environment, or movement of objects, or self-movement through the environment. And this is one of the ways that we perceive something to be an object, is how its perspective transforms when we move relative to it, or vice versa. And so this is...
What is this an example of?
Perspective transformation, which is an invariant.
Now, how is perspective transformation an invariant?
Okay.
It's an invariant of what?
Okay. It's an invariant ultimately in the structure of the light in the optic array that is picked up by the perceptual system. So, and now the invariant is what he calls a higher order invariant, and it's difficult to describe. When we, I had an aha moment not long ago that when you have an oscillation, you know, you have say a voltage signal that's oscillating. Well, it's constantly changing, but an invariant is its frequency if it's a periodic signal. So it is a pattern in the activity. Or it's what he describes as structure. Now, he doesn't give a nice mathematical description of the invariant here, but he calls it an invariant because there is the lawfulness, the correlation between the things that I pointed out about how the connectedness of the features are you know, creating a unity. It changes in a certain way. Now, if I put these slides in a different order, this is a series of slides.
No, I believe.
Yeah, if that would disrupt it. So if I shuffle the order, that's the disruption of the invariant. that distorts or weakens the perception. We would no longer be able to perceive a rotating rectangle at that point.
So it's the rotating rectangle itself that is the invariant, huh?
Not the rectangle, the way in which the relationship between the parts of the rectangle, which are going to have some, I'm not going to say representation, they're going to have some correlating component in the optical array, in the structure of the optical array. Each part and again, this is, I'm using a Cartesian object, so let's think of something like that chair over there as we rotate it.
I got it.
If the video was working, then there's one where they're using optic flow during driving. They're doing optic flow calculations, and you can see the way, as they drive down the street, you can see the way the objects,
Sure,
their outlines are changing. And so that's a perspective transformation. The lawful way in which Gibson states, without giving a computational description, that there is information in the way the outline changes that causes us or specifies the perception of movement relative to that object.
I believe that.
And that's because we've co-evolved with the environment to pick up on these lawful arrangements and use it to our advantage. Is that?
I think that's something Gibson would say, and I'm also going to argue that self-organizing dynamics has been a component of that coevolution, or a factor in that coevolution. So, okay, so that was my example slide for the perspective transformation. And so we'll go back here, and then I'm going to show optic flow afterwards, but we can revisit this slide again then also if you wish. But the idea, and we'll stress it again, specification by a lawful correlation, disruption of an invariant will weaken, distort, or destroy a perception. Oh, shoot. Okay. And then, so this is a photograph that I think gives a very good kind of visceral feel for what optic flow is. When we move through an environment, there is a center of our vision that's in the direction of motion where things really have the same structure in the optic array, and then the things that are around that center move radially away from it as we move towards the object that's in the direction of our motion. So you see there's a car on the road ahead, and there are lines in the photograph radially that point to that. And if we were in the car moving, all of these things, these parts of the optic array would be moving radially outward as we're moving forward. And that this is a lawful way in which the structure of the optic array changes as we move directionally. And it's another way that perception of motion can be specified. Now, a more kind of elemental way of looking at the pattern is given by these figures, which, if I remember correctly, they are from a Gibson paper. I may have just gotten them from this guy, Jack Treffner, who's got a nice website, metaAffordance.com, and he does some experimental studies on affordance perceptions in humans. And he's got some neat things and neat slides that are available. But so you can see, I believe, the translation one not as much, although you can see that there's a kind of a relationship between two fields of points whereby they've all been shifted in the same direction by approximately the same amount. And this is the sort of thing. These optic flow patterns, these are snapshots, and the actual optic flow pattern would be a sequence of points in the optic array that one visits as one moves through an environment. So I was going to show the video, and I think I closed a bunch of stuff. I'm going to see what happens when I open a tab, and if it takes super long time, then I'm not going to risk it. But, okay, that was promising. If it takes 30 seconds to load YouTube, then we will. Okay, maybe it's only going to take 15%. Okay, this is a short video. And Bob, I had the URL ready to paste, but I closed that document. So if you'll okay, this is a Internet Explorer thing that's often problematic on my machine. I have no idea how to get these things to. Chrome usually has "do not show this again," and I can make it go away and it never comes back, but Internet Explorer's not so nice. Okay. I had these waiting and ready to go. Okay, that didn't take too awful long. Here it is. Already 5 o'clock. All right. Not a good day for my videos. Okay, so these are nice things you can watch on your own if you like. There's that video that's 42 seconds long, and then there's one immediately following it where somebody, a guy uses, if you search that way, if you go to that video, then up next on YouTube will be the video of a guy who uses optic flow to do hand tracking, you know, and he shows how his algorithm tracks using optic flow. Now we're about to get to affordances. I'm hoping we have time to get to brains. I actually have only one slide on affordances. I think we've talked about them a lot and understand them, but there's a lot on this one slide. So affordances are action possibilities, and an interesting way for getting the concept situated. Gibson defines a niche in an environment as a set of affordances. In other words, the environment has things that enable the organism to accomplish certain things.
Sure.
And that's the defining characteristic of the niche. Is it a complete description of a niche? It might be. I don't know for sure, but Gibson said yes. Now, the affordance is that something has is determined by the properties of the objects, but not in an abstract sense of like feature, color, and size in millimeters and so forth. It's determined by properties relative to the organism. So if something is graspable, it's relative to the size of the organism's hand or claw. Reachable, their arm length or the length of their gait, how many steps it'll take for them to get there.
This chair affords seating not because it's 18 inches up, but because it's the right height for my body.
Yes, knee height. Knee height is steppable or sittable.
Exactly.
Knee height.
That's right.
And so Gibson sees this as an implicit meaning that's already present in the environment due to that coevolution. It's a meaning relative to the organism due to the coevolution, and it can be directly perceived. It doesn't have to be, digitized into an image and then some abstract computation.
It's already present in the environment if you're careful to include the organism as part of the environment.
Gibson says the word,
you've got both.
Gibson says the word environment doesn't exist without the organism.
Yeah.
And in
I'm happy enough with that.
yeah. So no, he agrees with that point.
So we took it here before, but
Are you trying to get something in?
No.
Oh,
the definition of organism itself, it's not a static thing, meaning that even if you just look at the basic growth cycle of an organism, the development cycle, those different sizes, what's graspable, what's reachable, what's comfortable to sit on, and has those affordances, changes over time. So it must be something that we adapt and learn. Maybe, I don't know what exactly, whether there's certain parameters that we can adapt within, but it changes.
Yes, and there's an action perception cycle involved in that whole thing, and I think that's where I think where this is going for me right now.
Steve, I want to talk about that directly perceived thing. So
Okay.
when it says directly perceived, am I right to imagine that let's say I'm walking in the forest and I see a stone or a rock that is of knee height, so I don't have to think or deliberate upon sitting on that rock or not. I mean, I can directly. It's more natural that I can sit on it without thinking a lot. Is that true? That directly perceived means that, or is it something?
I think a direct perception. I think that's part of it. I don't know if that's all of it, but think of animals that have quite a bit less deliberative ability than us.
Mm-hmm. Right.
And something, sitting is, I guess probably something that mammals or reptiles or, but fish or, not all animals sit. Insects probably don't sit, but support is one that's very common, and whether or not something affords support for walking on it. And that's, of course, water does not afford support unless you're a small insect, in which certain insects can walk, on the water, and so it affords support. And so they don't have to, take in an image of light reflecting off the water and perform some calculation in order to determine that the perceptual system evolves, or excuse me, it evolves in a phylogenetic way, but it also, in the developmental cycle of the organism, there are actions, some of which are instinctive and built in, hardwired, but there are actions that have results that are consistent, and that in varying property, causes the dynamical. Let me go to the next slide. Paul had to leave at 5. Okay, so he's not coming back. There is a reciprocal interaction between the environment and the organism. It's constantly changing, and I believe invariants are attractors in the dynamics of the ecosystem. There is, and that affordances are avenues for coupling. And in dynamical systems, there have to be loose couplings. The couplings can't be too strong, because then you'll have rigid kind of one-to-one sort of. But if you have a weak interactions in a system with a lot of interacting particles, according to Prigogine, then you can have a self-organizing dynamical behavior. And
give me an example. Go back for a minute.
okay.
Give me an example of an invariant as an attractor of the dynamics
Okay.
of an ecosystem.
Can I come back to that after showing you a slide or two? Because I think it may help.
And actually, I got another question as well. I'm not sure when this.
Go
Let me let you
ahead,
on.
go ahead, and we'll figure out. We'll put it on the.
I think it's related, but it might be a little tangential. So we talked before about epistemic actions and some other things like that.
Yes.
So when you say directly perceivable, that doesn't mean that the agent doesn't have to actively explore or take some kind of action to discover the affordances for itself. Meaning directly perceivable doesn't mean immediately perceivable, right?
Okay.
No. I believe you're correct. I think that the distinction, it goes back to philosophy and the Humean idea that I'm a little trepidatious of talking too much about this, but the representationalism is part of it. If you think of Brooks' Herbert robot and the way it interacted and used the world as its representation, there's something Gibsonian about that. And the idea that in direct perception, I believe one of the things is we see the world as it is. We don't see light, we don't see brain activity patterns, we see things. That's what vision is. And this idea that, there's this, noumenal reality, and then the Kantian idea of constructing the reality, Gibson doesn't agree with that, and I think there's a lot of debate. It's still very controversial.
Do you think internal environments, meaning simulation or things like that, could be used to discover affordances? Would that be a rich enough way of exploring these things?
Yeah, well, I think what I'm going to propose is that the inner environment is dynamically coupled to the outer environment, and so that there can be patterns in the environment which invoke patterns in the internal activity, and vice versa, and that there's a reciprocal interchange, and that's
Would that flavor the interpretation of directly perceivable in any way to you?
Huh?
If something, so if I'm using simulation and the terminology we've been using for mental imagery, Barcelona, things like that.
Okay.
Do you think that would in any way would contradict or in any way be in opposition to directly perceivable if there was that kind of a relationship?
Probably depends on who you ask, and I might even give you different answers at different times. I'm not sure I'm clear enough on it to be consistent yet. I would like to continue the conversation, perhaps tomorrow if we're available for that. But there was another. Bob?
Comment?
Please.
Let's see. First, a question. Who is your interrogator in the last 2 minutes? Was that Sean?
Yes.
Yeah. Hi, Bob. This is my voice.
So,
Yeah.
And Sean, let me pay you a compliment. As I mentioned before, to prime my readiness for listening to Steve this afternoon, I listened to that discussion at CCRG that I think you probably hosted some months or maybe a year ago, that was dealing with tetrominoes falling down. And you were talking about the relationship between grappling the tetromino, that is, catching it, Tetris style, and perceiving it. And to me, that's really at the heart of affordances. So it's that relationship between perception and I guess what I think of as premotor planning, a kind of prefrontal planning, in my view. I'll leave it there.
Yeah. Well, thank you very much. First of all, very glad that the content was useful, but also